Before knowing the other types of matrices, we have to know what is the principal diagonal of a square matrix. The principal diagonal of a square matrix is the diagonal drawn from the first element of the first row to the last element of the last row. First element of the first row is this one, and this is the first row. In this, the last row is this one. The last element of the last row is this. First element of the first row is A, and the last element of the last row is I. If we join these both, we get the principal diagonal of a square matrix. Join the first element of the first row and last element of the last row, we get the principal diagonal of a square matrix. Based on this, we can know the other types of matrices. The trace of the matrix is the sum of all the elements present in the principal diagonal. The principal diagonal of this matrix is this one. If we add the elements present in the principal diagonal of the matrix, it gives the trace of the matrix. So the trace of this matrix is, let this matrix be A, capital A. Matrices are always denoted using capital letters, and trace of A denoted in this way, trace of A is equal to sum of the principal diagonal elements, small a plus small e plus small I. This is called the trace of this matrix. Now let us learn about other types of matrices. Now let us see the 6-1 diagonal matrix. The matrix is said to be a diagonal matrix if any non-diagonal element, that is the elements which are not present on diagonals. Principal diagonal of the matrix are zeros. We will simply denote as Aij, in which if I is equal to j, then the element belongs to the principal diagonal. If not, it is a non-diagonal element, like this. In case of diagonal matrix, all non-diagonal elements are zeros. It is denoted in this way. Now, scalar matrix is a special case of diagonal matrix. In scalar matrix, the elements present on the principal diagonal are equal. Here, both the elements present on the principal diagonal are equal. It is a diagonal matrix since non-diagonal elements are 0. And the elements present on the diagonal are equal to a single value. So, such type of matrix is called as a scalar matrix. Let us see one more matrix, that is identity matrix. Identity matrix is a special case of scalar matrix. In this case, all the non-diagonal elements that are equal to zeros and the diagonal elements are equal to a value of 1. How many diagonal elements are present also, they will be equal to the value 1. If we take an example of a 2 by 2 matrix, this is a 3 by 3 matrix, we can construct a 2 by 2 identity matrix. It is also called as unit matrix. A 2 by 2 identity matrix would be in this way. All the principal diagonal elements are equal to the value 1 and non-diagonal elements are equal to the value 0. Now let us see what is a triangular matrix. A triangular matrix may be an upper triangular matrix or lower triangular matrix. The condition for a matrix to be an upper triangular matrix is the element Aij is equal to 0 if I is greater than j. That is, elements below the principal diagonal. That is, this element is A21. This element is A31 and this element A32. Here, if we see, the I values are greater than the j values. 2 is greater than 1, 3 is greater than 1 and 3 is greater than 2. All these values became 0. So it is called as an upper triangular matrix. The reverse to it is the lower triangular matrix. If if a matrix is a lower triangular matrix, then Aij is equal to 0 if I is less than j. This element is A1, 2, this is A1, 3 and this is A2, 3. Here if we see the I values are lesser than that of j. 1 is less than 2, 1 is less than 3 and 2 is less than 3. These elements became 0. This is an upper triangular matrix like this and this is a lower triangular matrix. Consider these examples.